Hello everyone, I'm Shindo from Singapore Management Universities. Today I will introduce our paper called Simple or Complex, Together for a More Accurate Just-in-Time Defect Predictor. Just-in-time defect prediction is to predict whether a commit is defect introducing or not. It can help developers to narrow down the debugging scope to commit level and avoid some defects at early stage. There are a lot of existing work working on this task. One kind of work is called simple models in our paper if they are using handcrafted features with traditional machine learning classifiers. Typical works are like LRGIT, DBNGIT, and LA-Predict. Those simple models are effective because there are some heuristics behind each handcrafted features. For instance, the number of lines added or deleted is a typical feature. The heuristic behind it is that the more lines of code added at the same time, the higher probability to make some mistakes. There are another kind of method is called complex model in our paper if they are using deep learning modulars to automatically extract features from the content of commit. There are only two deep learning based methods, DeepGIT and CC2Vet. To better understand the simple model and complex models, we summarize about the pros and cons of each kind of method. For instance, for simple models, the good thing is that it can make use of expert knowledge and have good interpretability because they use traditional machine learning classifiers. But this kind of method does not understand the semantic meaning of actual code change. For complex models, it can automatically extract features and capture some semantic meaning of commits, but they do not leverage the useful expert knowledge. Another finding is that the good thing of simple model usually is the bad thing of complex models. So we are thinking a simple model and complex model seems to be complementary to each other. Then it comes to our proposed approach. In this section, we want to aggregate in simple and complex model in some ways. Our general idea is like this. Given a code change, we can extract handcrafted features by the definition of handcrafted feature, and we can feed it to a simple model. Simple model may think it is defective because it changed too much lines, or maybe the author is not so experienced. And we can also feed the content of code change into a complex model. It may also think it is defective because they may find some token sequence or patterns that frequently shown in the defective commit. So as we can see from this illustrated example, these two kind of methods have two different ways to do decisions. So if we combine them together, we may get better performance, and we may also get more diverse interpretation. In this paper, we're focusing on getting better performance by combining simple and complex models. Then the next question is, how do we combine the simple and complex models? Our solution is to use late fusion. Late fusion aims to aggregating different data modality at the decision level. In our setting, we need to consider handcrafted feature and commit content as two data modality because handmade features are descriptive statistics summarized from content and they are tabular data. And for the commit content, they are commit logs and code changes which are non-structured data. So we can consider them as two different data modality. And what late fusion does is that it will aggregate in different modality at decision level or the prediction score level, which means that we will use separate classifier for each modality to do the classification task. Then we collect the prediction score from each modality and aggregating them by some rules like averaging it, multiplying it, or do linear regression between them, and we can finally generate a final prediction score. Then these figures show the framework of our proposed approach, SYNCON. As I mentioned before, we use late fusion techniques. That means we need two separate models for each modality. Simple models for the handcrafted features and complex models for the commit content. For the simple models, we use 14 handcrafted features with random forest as classifier to generate the prediction scores. For the complex models, we split the commit content into commit logs and code changes and use TextCNN as the deep learning modular to extract features and use fully connected layer as a classifier to do the prediction. After getting prediction score from each modality, then we simply average in the prediction score to generate the final prediction score as the output. Then it comes to our experimental settings. We use the same data set used in the state of our approach, and we evaluated method on three widely used metrics: AUC, ROC, AUC PR, and effort score. We compare our method with three simple models, including the state of our LA Predict, two complex models, and one ensemble learning approach. Here is the experimental result to show the effectiveness of SynCon. As this table shows, our approach can outperform all the baselines consistently on every matrix, and our method can outperform the best performing baseline by 6 to 18% in terms of three different metrics. We also plot the performance of our proposed approach and all the baselines on every project in terms of AUC ROC. As we can see from the figure, our method can consistently outperform all the baselines on different projects, and this phenomenon repeated for other evaluation metrics as well. Another question is, how do the component models of SynCon perform? We do an ablation study on SynCon, and the experimental result shows that simple plus complex always lead to better performance other than only using simple models or complex models only, which indicating that they are complementary to each other to some extent. In conclusion, we propose an approach that combines one simple and one complex model valet fusion. The experimental result shows that our approach can outperform the state of art by 6 to 18%, and we also find that simple and complex models are complementary to each other. For future, we want to explore the effectiveness of combining simple and complex models in other tasks, and also explore the interpretability of combined model. Thank you.